right, so I'll just get started. I hope everyone's doing good. It seems like a pretty intense back-to-back uh, conversation. I'll try to keep it as easy as possible. I'll just get started. Okay. Hello, everyone. My name is Jatin, and I'm a software engineer at Google. For the last 5 years, I worked in the web frameworks team here. I'm here to talk about the Wiz and Angular framework convergence. Every so often, there's a meme about how modern web frameworks are not that different from each other. It feels like they're fated to evolve to a point where they all have the same features with similar characteristics. It's like they're the same, but different, but still the same. In fact, even React has fine grained reactivity now. So, what is happening? Jokes and memes aside, there is some truth to this idea. Modern web frameworks on modern browsers are solving a problem space that's much smaller compared to 10 years ago. So this begs the question, why do we have so many web frameworks? A little over a year ago, a small group of framework maintainers at Google asked ourselves a similar question. Specifically, we asked ourselves, can Wiz and Angular converge to a single web framework? We arrived at an exciting answer that is deeply transformative for both frameworks. Wiz and Angular, the two largest web frameworks at Google, are converging. This talk will cover the hows and whys of this convergence. Why do the frameworks want to converge? How are the teams approaching this large and ambitious project? We will learn about the foundations of this convergence, reactivity and resumability. And finally, we will see what might be coming up in the future and how to stay informed or get involved. The first question you might have is, what is Wiz? Wiz is a proprietary Google internal web framework. It is used to build some of the largest websites that Google makes, like Search, Photos, and YouTube. In fact, it is likely that you used something built using Wiz in the last few days. It is easy to tell if your favorite Google application uses Wiz. Simply inspect the HTML of a server-rendered page and look for one of the following attributes: JS action, JS controller, JS data, or JS model. Wiz uses a pretty unique approach to make applications interactive that is based on these attributes. We'll get back to this point later in the talk. So now that we know what Wiz is, let's go back to the topic of Wiz and Angular convergence. Nearly 4,000 web applications made just at Google use Wiz or Angular. This includes some of the largest apps made by Google, like Search, YouTube, and the Cloud Console. In addition, Angular is also used outside of Google to make many web applications. Across these apps, the two frameworks serve millions of QPS per second, millions of queries per second from all parts of the world and a wide variety of end-user devices. The diversity in end-user devices is truly spectacular. It ranges from iPhones on a blazing fast Wi-Fi to a 5-year-old Android phone on a slow 3G connection. We also support feature phones running KaiOS and 8-year-old televisions hanging safely on someone's living room wall. Both frameworks care deeply about bringing everyone along as they evolve. Neither framework believes in making sudden, backwards incompatible changes that drop support for existing apps. Every change to the framework runs thousands of tests across this huge install base. Given this mind-blowing scale, why are the two frameworks even thinking about converging? So about a year ago, both teams were working on reactivity at the same time. As we talked more about this, we realized that the two frameworks are not that different from each other. With some careful co-evolution, the frameworks could share the same primitive down to the actual code that's running across thousands of applications. Possibly the most important part of a web framework is its ecosystem. Thanks. By converging frameworks carefully, we can also converge these ecosystems. It's a win-win where shared library providers now have a larger potential market and developers have a richer variety to choose from. In a small but important set of use cases, Google intentionally does not want to fragment foundational libraries. A good example of this is state management. Some of you might be aware that Google applications heavily use a technology called protocol buffers to handle structured data. If both Wiz and Angular use the same signals library, it becomes feasible for this foundational technology to consider integrating signals to provide a protobuf signal store. With Convergence, we greatly increase web developer mobility inside Google. Developers who join Google are much more likely to be familiar with converged concepts. Over time, as more and more code starts looking the same, we can also use the same tools to maintain them. This includes stuff like formatting, linting, and docs that encourage best practices. So how will the two frameworks converge? This is a large and ambitious project. It is also somewhat unique since two frameworks of this scale have never converged before. So we don't really have a playbook for how it should happen. One thing that both teams agree on is that we don't want to converge just for the sake of convergence. We want to take an intentional approach and ensure that every step makes sense for both frameworks. We care about delivering real value to developers and end users every step of the way. This convergence isn't a goal, but it's a way that the two frameworks choose to evolve from this point onwards. About a year ago, a small team from both frameworks spent a week discussing the idea of convergence. One of the outcomes was this picture here. It represents how we initially thought about convergence. While the specifics have evolved since then, the general idea endures. We started by describing the ideal end state. What would it look like to have a single converged web framework? And working backwards from there, we identified a few key milestones without worrying too much about how to get there. We identified risks and uncertainties that are represented in this picture as stopping points. The first two milestones in the diagram represent the two most foundational areas of divergence, reactivity and interactivity. These were identified as riskiest and most expensive to align if we were to converge. They're truly fundamental to how the frameworks operate. A quick disclaimer here. This picture isn't a roadmap or a sequence of actual milestones. In fact, it is a bit outdated already at this point, but I thought it is worth sharing because it's quite literally the first visual representation of convergence that we came up with. It is also as simple as it can be while driving home important points. Right. Unfortunately, the two frameworks had very different philosophies when it comes to these two things. Interactivity is how the framework responds to user interactions, while reactivity is how the frameworks update the UI when the data changes. To build interactive web applications, developers must write JavaScript event handlers and bind them to HTML elements. Wiz focuses a lot on minimizing the amount of JavaScript required to make an application interactive after initial render. On the other hand, Angular provides powerful primitives like dependency injection and directives, which require more JavaScript to bootstrap, but provide a great developer experience. One of the main things event handlers do is update data in response to user interaction. The framework uses a reactivity system to update the UI when the data changes. Wiz used a React-like programming model where developers set state and that causes the component function to rerun to update the UI. Angular uses a very unique approach based on zones and dirty checking to update the UI when the data model changes. Let's take a closer look at reactivity. To provide reactivity, the framework somehow keeps the data in sync with the UI. There is a fundamental choice here that the framework must make. The framework could keep track of exactly which part of the UI corresponds to a given piece of data, or it could give up and not do that. When the framework knows exactly what code to execute when some data changes, it can provide fine-grained updates in a very natural way. Since the amount of code that runs is minimal, optimizations like memoization are optional. This is also known as the data diffing approach. When the framework does not know exactly what code to rerun, it must run the same code that it used to initially render the view. At that point, without optimizations like memoization, recreating the entire view can be very inefficient. This is also known as the DOM diffing approach. Let's see a simple example to better understand this difference. In our example, the data model is a single number called count. The UI is a span that says even or odd depending on the count. The sequence of computations to go from the data to the UI are very simple. First, we check if the number is even or odd and store the result in a Boolean. Then, depending on the Boolean, we decide what the text of the node should be. In the DOM diffing approach, the developer simply writes out the code to convert the data into UI. It is pretty natural to do this. However, when the state changes, the entire function must now rerun. This means we end up recreating a span every time the function runs. But really, only the text is changing. To make this more efficient, the function doesn't directly update the DOM. Instead, it returns a data structure which represents the DOM, a virtual DOM. And then the framework compares the current VDOM to the new VDOM and commits any differences to the actual physical DOM. This part isn't obvious to the developer at all when writing the above function. Instead, the mental model is to simply turn the data into the UI. Until about a year ago, this was the recommended way to update the UI in Wiz applications. Instead of using a VDOM, Wiz used an open source library called an incremental DOM. In the data diffing approach, the developer has to identify the UI update flow when writing the component itself. So in this pseudocode, the developer is doing that by using arrow functions. When the signal changes, the framework doesn't rerun the entire component function. Instead, only the arrow functions that actually consume the data will be rerun. Nothing tries to delete the span, so there's no reason to try to protect it. About a year ago, both frameworks agreed to a shared hypothesis. And that hypothesis is that diffing data is better than diffing DOM. When diffing DOM, performance is opt-in due to the dependency on memoizations that are usually manually written. On the other hand, when diffing data, performance is opt-out, since by default, the framework runs the minimal possible code to update the UI. We also believe that the lack of a VDOM will help memory-constrained devices. So over 6 months ago, Angular adopted Signals and switched to this UI update model. This was a natural fit for the framework because of how it already worked. This change also allowed Angular to make zones optional. Wiz also switched to a signals-based UI update model around the same time. Angular signals now power UI updates in the YouTube mobile web app and other Wiz-based applications. We have a pretty high bar to decide when the hypothesis has been proved. Developers are excited to learn about and use signals. We are improving the debugging story, the production observability, and helping developers build an intuition for how signals work. Progress so far has been encouraging. We have delivered real value to both developers and end users, so we'll keep going down this path. Now let's take a closer look at interactivity. In modern web frameworks, developers write declarative event handlers, and the framework attaches them to the appropriate DOM nodes. In most web frameworks, including Angular, the sequence of events goes as follows. First, the framework loads all the event listeners that can appear on a given route. Then, during hydration, the framework instantiates and attaches those event listeners. Finally, the user can interact with the element and cause the event listener to run. In Wiz, the sequence of events is different. First, the framework listens to all events at the root of the page, and right away, the user can interact with the page, no hydration required. Upon first interaction, the framework instantiates the required event listener and delivers the event to it. The approach taken by Wiz is now also known as Resumability, thanks to a new web framework called Quick. Quick and Wiz take a very similar approach when it comes to interactivity. So this unique approach when it comes to attaching event listeners, remember those attributes I mentioned at the start, JS action and JS controller and so on. In Wiz, a small library called JS action is listening to all events at the root of the page. When a user interacts with this button, the browser bubbles the event up to the body where the JS action kicks in. It scans the DOM to see if there is a JS action attribute between the root and the target of the event. If it finds one, it instantiates the event handler and then delivers the event. Thus, the button controller is instantiated only if the user interacts with the button. In addition to being super lazy about when event handlers are instantiated, this approach also allows Wiz to minimize the amount of JavaScript that's loaded on the page. The event handler is loaded only if it is actually rendered on the page. This means if some part of the component tree isn't rendered due to control flow, Wiz will never even load the event handler JavaScript for that page, for that component. So in this example, if the span is rendered instead of the button, then the button controller is not even loaded on the client side. So what exactly does resumability mean to Wiz? To Wiz, it means that we load less code and we run code lazily. There is an obsessive focus on minimizing work during the render path. This includes both decreasing how much JavaScript is loaded and also how much JavaScript is run. So compared to resumability, a hydration-based approach requires that all event handlers be eagerly loaded. Further, event handlers that are actually bound must also be eagerly instantiated during the initial render. Just like we did during Reactivity, both frameworks agreed to a shared hypothesis. And the hypothesis is that resumability is better than hydration, since it minimizes the amount of JavaScript loaded and executed by the application. So to test out this hypothesis, Angular recently integrated JS Action and started exploring these concepts. Currently, it is possible to use JS Action to trigger hydration of deferred content. This kind of lazy loading and instantiation of event handlers is the goal of JS Action. When used correctly, content will be available to the user in the first round trip without adding any JavaScript to the application bootstrap. This should result in a better end user experience. So we have now seen the two technical foundations of convergence. But the real foundation is this exchange of ideas. Both frameworks benefit from the vast experience on either side. Wiz gets signals from Angular, and Angular gets JS Action from Wiz. So what's next in the Wiz and Angular convergence story? You can think of convergence like a series of gravitational waves as the frameworks circle each other, aligning on fundamentals one by one. We are already seeing JS Action and signals. As this wave progresses, they will be detectable in different forms. Developers will see new shared code, new APIs, and new features that build on these capabilities, and finally automated migrations to new ways of doing things. Additional fundamentals like dependency injection are in early stages of development. At this point, it's probably important to note that convergence isn't the only thing that the two frameworks are working on. In fact, at this point, it is even taken up majority of our time. Like I said earlier, convergence by itself isn't a goal. Instead, it is a guiding principle in the natural evolution journey of both frameworks. As we work through these framework foundations, we will likely discover building blocks that are generally applicable to all web development. For example, Wiz and Angular are not alone in betting on signals. Other frameworks like Vue, Svelte, Ember, Solid, Preact, Lit, and Quick also either use signals or allow developers to use signals to power fine-grained UI updates. As a result, we are participating in the TC39 standardization process to add signals to JavaScript. We are excited about other proposals like async context and DOM parts. In the future, it might make sense to standardize JS action by improving support for deferred event handlers in the browser. So here are some things you can do to participate or benefit from this work. Probably the easiest is to try out the new features in Angular. This includes the signals-based APIs and deferred blocks with partial hydration. When you do this, you are using the signals and JS Action code base shared between the two frameworks. You can also check out the TC39 signals polyfill on GitHub. Here you will find an implementation of the proposed spec that is pretty similar to the one being used by Wiz and Angular. Additionally, there is also a signals utils repo containing many useful utilities that build over the standard spec. Finally, all developers are also welcome to take a look at the actual shared code base between the two frameworks. This is the code in Angular that also runs on Wiz-based Google products like google.com and YouTube. If you have any questions or you want to chat more about web development, you can reach out to me on X. And that's all I have. Thank you for listening to my talk. I hope you found this useful. Okay, I am not sure what happens next.
Perfect, thanks. Thanks very much for the talk, Jatin. We have a few questions. First one is, can you share some lessons learned about soft skills that you come out from this process?
Sure. One of the main things that I learned from this process is to be curious, especially when someone is describing something that is very different from what you may have even imagined, or you are for some reason convinced that that is not the right way to do things because you're not familiar with it. You have to remain curious and get to a point where you kind of learn their perspective. And this kind of curiosity can be groomed, for example, by trying to build things yourself, even if they're just like small toy projects, and expose yourself to more like perspectives. That's probably what I would share, curiosity.
And maybe something like by working with colleagues or nothing very specific about that?
Yeah, like working with colleagues. So here in my case specifically, right, when we started talking more with Angular, it was such a different perspective about like how to build web apps, right? And so Angular had to be curious about how Wiz works, which is not obvious at all. It's very difficult to understand. And the Wiz team had to be curious about how Angular works, which with stuff like Zone.js and change detection, it can be a little mysterious at times.
Yeah.
And so that's what I mean by, you have to be curious about things that are just like not obvious to you. And that can help. And so sometimes like, you might be in a team where you have to start working with another team, like you have to start calling their APIs or something. And they're using some technology that you've tried in the past and just completely had a horrible time. Don't just immediately reject them and tell them, oh, this sucks, I tried it in the past. Instead, be curious about how they help their clients to use it. And maybe they figured out something that you couldn't in the past. And so it's actually not that bad.
Yeah, I know myself quite a few tools that were quite bad, but now they're better. So yeah, I, in sum up, don't like have hard feelings about things and stay open so that you can try a lot of nice stuff. Next question, how will this convergence affect current users of both Wiz and Angular?
Yeah, so I think that the users will slowly see new APIs and new capabilities that they can try out. And the goal, as usual, is that these new APIs and capabilities should make either the developers' lives easier or make the applications that they're building better, provide better user experience. So it can become faster for the end users, or just have it run less JavaScript, for example. And so it shouldn't change things significantly. You still expect what you expect from these frameworks, that slowly they will have new capabilities.
Yeah,
And if an existing capability is deprecated for some reason, there will be like migration tooling or some guidance to help the users upgrade and keep up. So
perfect.
I guess in summary, nothing major should change. You will just start seeing that there are more shared concepts.
Yeah, there's no breaking change and like you need to migrate and then it's like a mess. Um,
Exactly.
there, yeah, perfect. So that's a very good news, I guess, for a lot of developers that will be able to sleep well now. What compatibility issues have you faced and how are they being addressed?
So far, the biggest compatibility issue was about how the frameworks do UI updates. Like I mentioned in the talk, uh, Wiz had this React style programming model with like an IDOM, which is really a different kind of VDOM. And Angular was doing like dirty checking and having some system to poke the framework saying, hey, now you should do dirty checking. And that system was typically Zone.js, but then they introduced like on push, and then now there's like signals. And so aligning both the teams on using signals was actually really, really challenging. So the way that we addressed it is we picked a particular Wiz application that would have really benefited from using signals. This application was the YouTube mobile web app, which runs on some really low-end devices. And so on those devices, there is a lot of memory constraint, and even the processing is pretty bad. And so there was a lot of pressure to try to run the minimal possible code. And with signal-based updates, we were able to do that. And so the way we addressed this incompatibility was we found the best use case for it, and then we just put the hypothesis to the test.
Okay, yeah, that's probably the best one of like just having something practical to fix and to improve. Still the best way to go. Um, Perfect. Do you have any last words for us, maybe?
No, I had really good time speaking here. Thank you for inviting me.
Yep.
And if anyone wants to reach out or chat, you can reach out to me on X.
Perfect. Thanks very much, Jatin. Have a nice day.